is going to be our last day with nomenclature, right? So hopefully there will be another assignment that you guys will do. But for the most part, we should have all the tools that we need. And I'll let you guys try to work this weekend on completing your final nomenclature assignment. All right, the next thing that we need to start talking about on Monday will be some other features to get us prepared for our second exam. I know you guys are still waiting on your first exam. I'm working on getting that completed. I'm sorry, just some things came up. Also, there's some issues with Canvas. It's not working well, so it makes things a little bit slow on my end to go back in and to grade everything that was done on Canvas. But I'm working on it. It's not an excuse. It just takes a little bit longer with classes being done this way. So hang in there. I definitely will get that stuff to you. I know that's very important to you guys. Also, I'll get the midterm stuff back to you, and then we'll talk about the second attempt on the midterm, right? But for now, just hold off on that. All right. What's very important for you guys this weekend is to go ahead and recomplete your homework. All right. I've opened all the homeworks, and I have allowed you guys to have 6 attempts at the homework. All right. So you want to take advantage of that to earn the maximum points that you can. I'm hoping that running through the homework multiple times will get you guys those skills that you would need to be able to do well on tests. All right. The number one thing that I can see from this class is that it just looks like there's not enough work done outside of class. So that has to come from you guys in. There's Canvas, there's different online programs and things that you can use. And obviously, I have a few quizzes and groups assignments that I try to assign. If you can work on those problems and commit the skills to memory or to have those skills ready for a test, you'll be well in this class. All right. So I'm hoping that everyone will heed to that advice and aim to do better. All right, let's go ahead and see. I'm going to do a show of hands really quickly. If you can see my screen and also hear my voice, would you mind just raising your hand in class, Curly? Okay, I see about 4 hands raised. So for the most part, assuming that everyone can see and hear the screen. If you cannot see or hear, would you mind raising your hand or speaking up? If you cannot see the screen or you cannot hear, would you mind speaking up now? Okay, I'm going to assume that everyone can. Let's go ahead and start moving into nomenclature. Let's review really quickly. All right, let's go ahead and put nomenclature here. Sorry, I don't have my keyboard in a good space. All right, there's 4 things that we need to be able to do to properly name a molecule. All right, what is task number 1? I need to be able to identify the parent chain, right? You guys have been working on this. I'm not going to put the finer details there. I think you guys have all that sent to you. The second skill that I need to be able to do is to number the chain, right? Once I find the parent chain, I need to number the chain. And I need to make sure that the rule when it says for numbering is that I give the lowest numbering for all substituents. So rule 3 says now is deal with substituents, right? And what does that all means when I have to deal with substituents? I need to make sure I keep in mind its location. I need to be able to name the substituent correctly. Is it branch or is it straight chain? And then I also need to be able to deal with any multiplicity that comes up. And the last rule here for nomenclature is to go ahead and name the molecule. But I need to make sure that I start with substituents. I'm just going to put subs here. Then your prefix of the parent chain, and then your suffix of the functional group. Okay. So if I gave you guys this molecule here, and I wanted to, actually, I want to change something here. And I wanted to name this molecule. Can you guys help me out? How would I do this? What's my first skill I need to do to name this molecule?
Find the parent chain.
Okay, so the skill one is to go ahead and find the parent chain. Can anybody help me out with the parent chain? All right, so in this case here, there's a triple bond, right? So that triple bond has to be included in my parent chain. I'm gonna start my one here.
Dr. Cooper, my sister can't get into class.
Okay. What is that supposed to mean? She want me to call you want me to call her?
Yeah, she tried getting in. It's not giving her the option to join.
What is it giving her?
No option at all. She put it in the chat thing, but she didn't see it or not paying attention to it.
Yeah, it didn't pop up on my end. All right. And she's in the right class?
Yeah, Miss Brown is in his class.
No, no, no. I mean, if she's in the right room, I guess I should say that. Because if you're in teams, if you're not in this specific class, you won't see the link.
Yes, sir. Yashika Brown is in this class.
I don't think you understand what I'm saying, but it's okay. I know that she's part of this class, but she's not in the room because I don't see her chat. So she's speaking in a different room. That's what I'm trying to say.
Okay, can you try to call her so she could join the class?
Sure. Okay. So this is my molecule, and I know that I have a triple bond that has to be included in the name. So I'll go ahead and say 1, 2, 3, 4, and I can say 5, 6, or I can come down and do the same thing, right? I can say 5, 6. So it doesn't matter if I went straight to the left or if I went straight down, I get the same numbers. So I'm going to go straight across here, and I get a total of 6 carbons in my parent chain. Is there any questions initially with trying to identify the parent chain? Okay, good. No questions there. All right, let's go ahead and try to work on now dealing with the numbering. Did I number this chain correctly? All right. So here I have my double bond at carbon 2, and I could number the opposite way. Three, 4. Okay, if I number the opposite way, do I get my carbons or do I have my substituents in the lowest possible number? All right, that's what we're going to have to check. So let's go ahead and just do a crude check of where substituents are located. In red, can you guys tell me where substituents are located? Okay, 4 and 5, right? Is there any questions there so far? No questions? All right, so if I took a look at the red, a double bond starts at 2, gonna have something at 4 and I have something at 5, right? I took a look at gray. I have a centroid at 2, centroid at 3, but I have my double bond starting at 4, right? So up top, this is a 11, and down here, this would be what? 9, right? Okay, so it looks like the gray will be preferred, right? But there's an issue here. Can everybody see so far that it looks like the gray is preferred? Whenever I have unsaturation, or if I have a triple or double bond, it's going to dominate. So the double bond is going to dominate the numbering, give it the lowest possible number. Okay? So gray gives a double bond starting where? At 4 versus the red that gives a double bond starting where? At 2. So which one is lower? Gray or red here?
Gray.
Yeah. Who's lower?
Gray.
Yeah, the red, right? The red is what you want. The red is going to be preferred for this molecule. All right, let's go to make sure that I highlight that for you guys. All right, so keep that in mind. That could be a something now that we're learning. All right, that this red is going to be preferred for the lower numbering for the unsaturation. All right, I can't grab it like I want to. Okay. All right, so let's go ahead and move to the next number here. So I got the parent chain. I think everybody's cool with that. It's a chain moving straight across. All right, I numbered the chain correctly. I know red is the correct way to number, not because it gave me the lowest constituent count overall. It's because of the double bond. The double bond is going to dominate. I should always give it lowest if I can. So it's better to have the double bond at 2 than it would be at 4. Now I need to deal with my substituents. I got 2 substituents hanging off 4 and 5. What do you call the substituent hanging off carbon 4? What's that called? How many total carbons inside the box?
2.
Not 2. One more time.
3.
There's 3. 1, 2, and 3, right? So there's 3 carbons in this box. So I'm in the 3 carbon family. So what is the 3 carbon family's prefix?
Try.
No, that's multiplicity. Prefix. Mother eats peanut. So the P there stands
Oh, propyl.
propyl. So this is the propyl family. Is this a regular propyl or this is one of the branch propyls?
Branch.
Yeah, this is branch. What's the name of this one? This is an isopropyl group. All right, 3 carbon family, but it's not straight chain. So we call this isopropyl. All right, what about up top? What is this extension called? 1 carbon inside the box. What is it called? A methyl substituent, right? All right, so I've dealt with my substituents now, and I'm ready to name my molecule starting with my substituents. So the I is used alphabetically for isopropyl, and the M is used alphabetically for methyl. So who comes first out of isopropyl or methyl? I, right? I comes before M alphabetically. So I start off with my location for substituents. Where is the isopropyl group located? Hello. Am I just talking to myself?
Say, I'm at work today. That's why I ain't answering a whole lot of questions.
Okay. I understand. I wish I didn't have to work, but I understand. That's what you gotta do. Is Brown's the only person to know how to name compounds?
You
Well,
naming the whole thing?
not yet, but we want to start with substituents. I just wanted to know what's the location for isopropyl?
4.
Okay, thank you, Ms. Brown. Mr. Barnes, Mr. Nichols, Ms. Nichols, Ms. Daniels, Ms.
I
McDaniel,
guess
Baldwin, Ms. Williams, Prentice, Banks, Malone, Bo, Gaines. Everyone's quiet. You guys are in class. What's going on today?
Nah, my Wi-Fi was tripping. I had to hook up my Ethernet.
Okay, I understand.
And my baby crying, so I'm trying not to have him in class crying.
Okay, thank you, Ms. Baldwin. What about everybody else?
I'm in the car.
All right, y'all really
I'm
making
on the street, so it's like
a stretch. Okay, okay. All right, since it's y'all got a quiz coming. All right, I don't know what's going on. The only way I get some feedback if I got to see you guys do a quiz. But you guys have a group activity, but there's going to be a Canvas quiz or a Teams quiz. I know there's something going on with Canvas right now, so I might put it in Teams. Please make sure you guys are with me. Please make sure you ask the questions. You do not want to sit on this stuff. All right. The best way to learn is to be active. Right. You want to learn how to fish, you got to go out and fish. You want to learn how to run, you got to go run. If you want to learn how to do chemistry, you got to try problems for yourself. Right. So I'm going to try to make sure that we are doing that. The isopropyl substituent comes first alphabetically. So it's going to be 4-isopropyl. All right. Then my next substituent is the methyl. It's located where? That's right. Thank you. 5-methyl. All right. So I dealt with my only 2 substituents. What's next? The prefix for the parent chain. And what should that be?
hex.
Hex. All right. I have a triple bond in my system. So at the end of the molecule, we indicated that's where we should talk about our functional groups. So I'm going to go ahead and say where my triple bond starts, which is on carbon 2. So hex 2, and then the functional group ending for this molecule should be what?
YNE, ain't it?
That's right. Thank you, Mr. Barnes. So this molecule is 4-isopropyl, 5-methyl hex 2-ine. Not too bad, right?
Can you explain again why it's red versus gray?
Yes, because it's the numbering for the triple bond that dominates. It has to be lower than the gray number. So 2 is where the double bond starts in red, and 4 is where the double bond starts in gray.
Oh, okay.
So because the 2 is lower, it's going to dominate the number.
And on the end, why is it YNE again?
Because of the triple bond. So it's an
Okay.
alkyne. So alkyne
Yeah.
has N and YNE. Good questions. You want to know that, you got a quiz coming up. I'm going to ask you to type in names. Okay, let's keep working on these. All right, what if I gave you this molecule right here? All right, this is a little bit more complicated, but could we name this molecule? So what are my steps again? 4 steps. What is step 1 to be able to name molecules?
Find the parent chain.
That's right. Find the parent chain. Where's the parent chain at? Maybe it's going straight across, right? Okay. Good. Let's go ahead and put some numbers somewhere. I started my numbers where the double bonds are at. Why do you think I did that? Or the triple bonds are at? Because typically they got to be the lowest numbering, right? So if I see a triple or double bond, I usually start my numbering there because that will give me the lowest possible number. All right, let's bring this down a little bit. Let's go to 8. Okay, is there any questions so far with finding the parent chain and then I numbered the chain this way? Any questions so far? Okay, no questions. Let's go ahead and identify the parent, the substituents. So rule 1 says find the parent chain, and rule 2 says go ahead and number that chain. And I knew to number it this way because I'm starting closer to where the triple and double bonds that will give it the lowest possible number. All right. The next thing here is to go ahead and deal with substituents. So where are my substituents located? There, there, and there, right? Any questions about those substituents?
On number 7, how would you to
Okay, I couldn't hear that. Can you give me give me 1 sec? Let me I need to mute myself real quick. Give me 1 sec and I'll come back to that question. Okay, one more time, Miss. I'm so sorry, Miss McDaniel. I think I hear you, just very low.
number 7, since there is 2 of them coming from like the point of 7, how would you do that?
Yeah, how do I know there's 2 substituents coming from 7? That's the question.
No, like how would you name that? Or would you
We'll get to it. We'll deal with the substituents at 7 in a few. Okay, good question. You see there's 2 substituents on 7, how to deal with them. We'll deal with it shortly. Any other questions that came up? Okay, let's go ahead and name the substituents before we deal with them fully. At position 6, what is the name of that substituent?
Ethyl.
Yeah, that's an alpha group. Very good. All right, at position 7, what are those substituents named as?
Isopropyl.
No, 7 is not an isopropyl. How many carbons
Methyl.
do you see inside of the box? Just 1 carbon, so they're both methyl substituents, right? Okay, is everybody comfortable with that?
Repeat what you just said.
Okay, I think I said that they're both methyl substituents. If I look inside the box, there's only 1 carbon each, right? This box only has 1 carbon, that box has 1 carbon. So the only way to describe a 1 carbon substituent is with the word methyl. All right, I placed in red the alphabetical letter. So alpha is alphabetically at E, and methyl is alphabetically at M. Okay, so the last rule says is let's go ahead and name this molecule. All right, we need to name the molecule where everything is starting in alphabetical order. Then we take the prefix of the parent chain, and then we end with our functional group naming, or the suffix for the functional group. All right, that's going to be different from this molecule. So let's go ahead and work on that. Where are our sustentions located?
6 and 7.
Okay, so we got things at 6 and 7, and then we got a triple bond and a double bond that we also have to deal with, but we'll deal with that at the end. So alphabetically, who comes first?
Ethyl.
All right, so 6-ethyl. Then I need to deal with my sustentions at 7. How do I deal with that? This comes to Miss Daniels' question. 7, 7 what? Dimethyl, right? So I have to indicate that I got 2 sustentions on 7. So I use the number twice, 7 and 7. And because they're both the same, I have to use the multiplicity rule, which is di. So this is 7, 7 dimethyl. Is everyone comfortable with that?
Yeah.
Okay, great. And then I have how many carbons in my parent chain here? What's the prefix for the parent?
You said what?
What's the prefix for the parent chain here? Yeah, oct. Because there's a total of 8 carbons in the parent chain, right? All right, now I have to deal with my unsaturation. Double bonds come before triple bonds. So my double bond starts at carbon 4. I'll say 4E. All right, I can't put the last E there because that will indicate that there's nothing else. So you say E. Then I would say 2-ine. Right, that's the name of this molecule. So this is 6-ethyl, 7, 7 dimethyl 4E2I. Okay, is everyone starting to get comfortable with this?
Yes.
Okay, good. Let's keep working. Yeah, that's fine. Let's do some other things. All right, so far we've done triple bonds and double bonds. And this is just a reminder. I'm going to put this here for a reminder. Right? If I got alkanes, you guys know that should end in ane. If I have alkene, that should end in ene. And if I have an alkyne, that should end in ine, right? I think somebody was trying to add to the class. Just add
It's
them
okay.
back.
I figured
Right.
it out. I was confused just about
Hello?
you-
Yep, I can hear you now. So one more time.
I said I was just thinking about the double and triple bond, how you would name it, but I see how you did it.
Okay. Good. Everybody's getting comfortable with that. All right, let's do another reminder really quickly. All right. How do I deal with alcohols? What's the ending here? All right. All right. How do I deal with ketones? On, right? How do I deal with aldehydes? Al, right? Okay. So let's work on a few of these right quick if we can. All right, let's say I gave you this molecule. How could we name it? Can anybody help me out?
Parent chain is in the middle.
All right, let's find the parent chain. Where's the parent chain at?
It's in the middle.
All right. I'm gonna go 1 here, 2 there, 3, 4. I'll go back up for 5. I just want to be different today. Is that the parent chain you guys saw?
Yeah.
Something like this? All right, keep in mind, it didn't matter if you did 1 here or 5 there, or if you did 5 up there, or if you did 5 there and 1 here. Right? It didn't matter. They're all the same chain. Right? Is everybody comfortable with that so far? Rule 1 says find the parent chain. Rule 2 says number the chain. Is this the best way to number this chain?
I think going like bringing them down like 4 just made it easier. Like bringing the 1 down the first carbon.
Okay, I'll do that one. You wanna start 1 here?
Yeah, I just think it makes it easier.
You wanna put 2 here, 3 here, 4, and then 5. That's what you want to do? That's okay. We can do both. Let's do both. I think both gives us an opportunity for a teachable moment here. All right, so you want to keep your eyes on things. If I'm in red, actually, you know what? I think this is confusing me, so I don't like that. I'm just going to move the other numbers to a different molecule. Let's work with the red first. Where are my substituents located?
2, 3, and 4.
Okay. For now, I'm going to ignore 3, but yeah, 3 is also a substituent. Actually, we'll do that. Okay, so I have these things in boxes. So if I had to look at my numbers for substituents, you'll tell me that I got things that to be read. 2, 3, and 4, right? If I had to total that together, that would be 9, right? Everybody's comfortable with that, right?
Yes.
All right. I have a second molecule. Where are my substituents located here?
Which one? Oh, the second model. On 2, 3, and 4.
Okay. So these are what to each other?
Parallel.
Or they're identical. They're the same chain. Right? There's no difference. All right, so that's the teachable moment. It's okay. You want to convince yourself that you do have the right numbering. And if you need to, you would do this. You will take both numbers and double check. But they're exactly the same. Right? So these two numbers are identical. So that's good news. That means that doesn't matter which which molecule we number, they're both okay. Right? Any questions right now for anyone? Okay, very, very good. So let's go ahead and work on the red since that's the one I started with. All right. Rule 1 says find the parent chain. Rule 2 says number the chain appropriately. And then rule 3 says deal with my substituents now. So what are the substituents? What are the names?
Methyl.
Good. This is a methyl. And there's also another methyl where? over here, right?
Oh,
Right,
I got
good.
page.
Methyl, methyl. All right, I'm gonna bring that down. Okay, so let's try to get class. I'll let them in. All right, great. And this group at 3 is not a true sustentaculant. All right, it's gonna dominate the name, so it's gonna be our functional group. So for now, we don't have to worry about naming it. All right. So rule 1 says find the parent chain. Rule 2 say number that chain correctly. Rule 3 says deal with your constituents. Make sure you know the location. You look for multiplicity and all that. Do we have multiplicity here? We do. We got methyls, 2 of them, so we need to be prepared for that multiplicity. All right. And then the last thing says now we can go ahead and name our molecule, starting with constituents, having our parent chain prefix, and ending with the functional group suffix. So in this case here, I got methyl groups on carbons 2 and 4. So I'm going to say 2 comma 4 what? Dimethyl. Right? Is everybody comfortable with that so far? There's a multiplicity. I got the same constituent twice, both on location 2 and location 4. So 2 comma 4 dimethyl. How many carbons in my parent chain?
5. Yeah.
So that's going to be pent. Good. Do I have any double bonds or triple bonds here?
No.
No. So I'm going to say and, right? That's an alkane.
Yeah.
I do have an OH group, and that makes the molecule a what functional group? This functional group here is an alcohol. So I have to end with my functional group. So this is 3 all. All right. So this is 2,4-dimethyl pentan 3 all. How are we feeling so far with that?
Yeah, that's
Not too bad, or is it pretty bad?
nah, that's cool.
Not too bad. All right.
No.
Let's keep trying. Let's keep working. All right. If I ask you guys to name this molecule, what is its name? Anybody help me out here? What's rule
It's
1?
8 in the parent chain. Is it an alcohol?
Okay. Somebody says 8 in the parent chain. I'm going to start here. 1, 2, 3, 4, 5, 6. All right. I only got 7. Did I miss the parent chain somehow? 1, 2, 3, 4, 5, 6.
7, I miscounted.
Okay, that's all right.
Should there be one on O?
Say that one more time.
Should there be one on O?
No, because I got to count carbons. Only carbons.
Oh, right, sorry.
No, you're all right. You're all right. Good question. That's a good question. Make sure you guys are counting carbons. Because alkyl names, the prefixes are only for the number of carbons. So meth, pro, pent, all that. Carbons. But good. All right, this gives me a total of 7 carbons in my parent chain. If you want to, you can't start your chain up here. You could go 1, 2, 3, 4, 5, 6, 7, but you'll be skipping out on this. And this is going to dominate the functional group. So that's a kind of like a rule of just trying to think of how to really say that. That's just kind of I guess you would say using your chemical sense. Like you want to make sure that you're numbering the functional group. So you don't want to skip that carbon oxygen double bond for potential numbering. All right. Um, it's going to throw off your functional group name. Okay, good. So I got 7 carbons here. I need to make sure I have the lowest possible numbering. All right, in this case here, the carbon oxygen double bond has priority over any other group. All right, so that means that it should have the lowest numbering. It should get a 1. All right, everything else is just a carbon with hydrogens. So we have a carbon with hydrogens versus a carbon with an oxygen. If I could, I'm going to make sure I give it the lowest possible number. And the lowest way is to go ahead and give it a 1. All right, this is typically the case always with this functional group. The carbon that has a double bond to an O will always be number 1. Okay, so you keep that in the back of your mind. So we found the parent chain, and now we know that we have numbered it correctly. I need to deal with my substituents, which is here. And what is the name of this substituent?
Ethyl.
This is the 2 carbon substituent, so this is called an alpha. All right, can you guys now help me name this molecule?
But I have a question.
Yeah, sure, go ahead.
In the box, there's 2 carbons, but on right on the number 3, do you count that carbon and the 2 in the box?
No, you don't count that carbon. It has a number, so it's part of the parent chain. Just the carbons.
Okay.
Just the carbons that do not have numbers.
Okay.
Okay, good. So I got 3 carbons. Well, on carbon 3, I have a substituent, so I'm going to say 3 ethyl, right? Then my parent chain is going to be what? A total of
7.
7.
all right. So what's the prefix for 7?
Helped.
Helps.
Yep.
Very good. And I don't have any double bonds or triple bonds, so I'm going to say and, right? Because that's alkane like. And then I do.
Wait, isn't there a double bond at 1?
That's a double bond to oxygen, not a double bond to a carbon.
Oh, so it has to be double bonded to a carbon?
That's correct.
Okay.
Yeah.
Sorry.
That's okay. To change the functional group to EN or YNE. But what is the functional group at 1? When I have a double bond to an oxygen like that, what is that functional group called? All right, this is where you guys need to.
Is it a ketone?
Not a ketone, but that's close. This is an aldehyde, so this gets the ending al. And you don't have to say 1 al because the functional group here is always at carbon 1. So most people know that it's 1 is default. All right, so keep this in mind. Carbon oxygen double bond with an H on this side, an O here. This functional group is always known as an aldehyde. All right. In this case here, the H is understood, right? You guys know how to count the number of H's on a molecule. This H right here.
What is, for the ketone, what is that double bonded to?
Oh, give me 1 sec. I'm so sorry. Sorry, I had an issue here. One more time. Sorry, Ms. McDaniel.
For the ketone, what is that one?
Yeah, a ketone has a double bond O in between 2 carbon groups.
Oh, okay.
Okay, good. And don't forget, there's a study module for functional groups. You guys want to get that down. All right, you guys want to be as comfortable as you can with functional groups. I think that study module will help. All right, this H was understood to be there. That's why you didn't see it, but you had to kind of know that this carbon had a total of 3 lines. So that means it had a H understood to be there. So most people don't draw the H for aldehydes, but you can. but a carbon double bond O with a carbon and an H is an aldehyde. All right. Any questions there? All right, let's keep working. And a bit too difficult. Okay, let's say I gave you this molecule. Oh, my computer's acting out. Come on, come on, come on. All right, I'm just trying to make a line. I have to make it by hand. All right, if I gave you this molecule right here, can you guys help me out? How would I name this molecule?
Wait, that's an aldehyde, right? No, that's a ketone.
Yep, this is a ketone. Very good.
So the parent chain is in the middle.
Okay, so I'm hoping that.
There's 5 carbons.
Okay, good. So let's say there's 5 carbons in the parent chain. All right, I'm gonna bring 2 versions of this molecule up. I think there's a teachable moment here. So let's work on this one. All right, so if I wanted to go ahead and number the chain, I can start 1 there. Oh boy, this is inconvenient. 2 here, 3, 4, and then 5. What's the settings on that? That's a 9. That should be a 5 there, right? Or I can go away.
You can go the opposite way. Like you can put the 1 down, like further down, or you go the opposite way.
Yeah. 1, 2, 3, 4, or 5. That way, right? Right. So I can do either one of these 2 ways to number. I can number things this way, or I can number things this way, right? Is everybody getting comfortable with that? Is that yes or no?
Yes.
Okay, good. So where will my distinctions be?
3 and 2 for the first one.
Okay. I'm gonna ignore the double bond for the most part. It is important, but because I know it's part of the functional group, I'm gonna ignore it for now. All right. But yeah, there's something at 2 here, and there is a double bond at 3, and the other one has a double bond still at 3, but it has also something at 4. All right, so which is the correct way to number? Is it the right or the left?
Couldn't it be either? Because it's on the 3 and there's a double bond on the 3 on both of them.
No, this one can't be both. Right? There's a reason. They're gonna get 2 different names. So it doesn't matter if they give the same name. So we go back up here. This would give the exact same name. This would still be 2-methyl or 2,4-dimethyl, and then your pentanal 3-al, right? Sorry. So this is exactly the same as this name here. But if I name these 2 compounds, they have 2 different names. So that means that one name is correct and the other isn't. How do I know which one is the correct name?
It's whichever one has like the less number when you add them up.
Yeah, the lowest numbering. That's correct. So here, if we took a look at the molecule on the left, if I took 2 and 3 into consideration, that gives me a 5. But if I look at the molecule on the right, I'm going to take 3 and 4, and that's going to give me a 7, right? So who has the lowest possible numbering?
The one on the left.
Yeah, the left. So this is incorrect numbering. Keep that in mind. All right, so this is not the correct way to number this chain. All right, so this is. All right, so I'm going to put left up top here. This is good. So now we are somewhat ready to name this molecule. Can you guys tell me the name of that substituent?
Methyl.
So methyl substituent. Very good. Very good. All right, let's go ahead and name this molecule. So I start with my substituents. So what will you tell me?
One methyl,
Two.
two methyl,
Good. 2-methyl. What's next?
There's 5 carbons.
Good.
So, pent.
Good. Pent. Then do we have any carbon-carbon double bonds or carbon-carbon triple bonds?
I have a carbon-oxygen double bond.
Carbon-oxygen double bond. So that changes things completely. But since there's no carbon-carbon double or triple, this is going to be kind of like an alkane. So we have to use the word ane. Hey, how are you?
I was trying to see
What room?
yes, sir. Oh, I got the room. I just didn't know.
What machine? Can you give me 3 minutes?
Yes, sir.
I'm almost done.
Yes, sir.
Thank you so much.
Sorry.
Oh, no, you okay. You okay. All right. 2-methyl pentan, because there's no double bonds or triple bonds to carbons. And then I need to deal with this functional group. So I have a carbon-oxygen double bond, and Ms. McDaniel told me because it's between a carbon here and another carbon here, this functional group is called a
Ketone.
ketone. So my ketone starts on which carbon?
3.
Right. So this is going to be 2-methyl pentan 3-one. All right. Not too bad. All right. There's some more work we need to do. So you guys will have a quiz this weekend. I'm going to try to work on some more lecture notes for you guys so we can put this whole thing together. We're going to have to cover some more functional groups, and then we're going to cover what happens when you have multiple functional groups in a molecule, what predominates. And then we'll be finally done with nomenclature. You'll know how to name most common organic molecules. Then we'll move into conformations and stereochemistry, and that will end the second half of this course. We'll take an exam, and then in the latter half of the course, we'll just focus on reactions. You guys will learn different reactions and try to predict the major products. All right. Thank you guys for tuning in. I will send this to you guys as a set of notes. I'm also going to be working on some notes this weekend. Give me 1 sec. Let me stop the recording, and then I'll take any questions anyone might have.